Hi, I'm Arafa and I'm currently studying PhD in Center for Neuroscience Studies at Queen's University. Today I want to discuss my master thesis that I did at University of Tehran, Iran. My master thesis is modeling the temporal dynamic of neurons in IT cortex. We know that history of information received in each stage of visual processing is really important and impact the visual neural response in each time point. So we are trying to use a feedback of history of information in each time point that we are trying to predict the neural response at each time point. For this study, we did an experiment that single-cell recording of neurons in IT cortex and at the same time images from different categories in different levels of abstraction are shown to two macaques. So in this RSVP task, we are trying to extract the neural response of monkeys for each image that they can see. In this work, we designed a model. This model includes two main stages. In the first stage, we are trying to extract the feature map of those images that are shown to monkeys. And for that, we use pre-trained ResNet 18 as a great tool for feature extraction of images. In the second part, which we focus on this part in the study, we are trying to predict a spike count of each neuron in each time point that we have. So in each time point, we have two kinds of information as input. First, the feature map of image that is shown to monkey will be one input, and another one is a neural response of the time window, including 20 milliseconds before the time point that we are trying to predict the spike count. So these two kind of input will be combined to each other. After that, we have pre-processing stage, which includes normalization and dimension reduction. And after that, because spike count has Poisson distribution in the brain, we use Poisson GLM as the simplest model for that part. After that, we have neural response of the specific neuron for the particular image in each visual task that we did. As a dimension reduction methods, we have different methods, and the controversial one is PCA, which use the most variant component in feature space as the best components in dimension reduction. However, we have another dimension reduction method, which is unsupervised approach, and the name is smoothing index. This concept is based on the distances between different data points in input space and output space. It means if each component can map data points in input space to output space in a way that distance between different data points are kept, so it will be rewarded. If not, we will punish using ReLO function. So if the data points are really near to each other in input space, this component should map these data points in a way that they capture a lower distance between each other in output space as well. Another method that we are using is separability index. Separability index is defined as proportion of distance between different data points in one cluster to distance between clusters. So it means when data points are really near to each other in one cluster and far away from different cluster, separability index will get a larger value. As a result, we can say that if we use this feedback of visual information for each time point, we are able to decrease unexplained variation of neural response in the model. So we can say that feedback is really important, and we should consider history of information to predict a spike count in each time point. In addition, when we use a smoothing index as dimension reduction method, the ratio of change of performance in the model when we add feedback will be increasing. So we prefer this method as dimension reduction. We can see single neuron response for each image, for each neuron. And you can see that this model can capture most of the behaviors and temporal dynamic of neural response in the artificial neurons. Because there is variance in single neurons data, we can see population neural response as well. So you can see that the value of correlation shows that this model can capture neural response in like really similar to real neural response. For most of images, this correlation value are more than 80%, and it can show the power of our model. So we are interested to see if temporal dynamic of separable index representation for different categories and in different level of abstraction are similar to each other. We know that in anti-cortex, separation of different categories will occur at about 100 milliseconds after onset of stimuli. So we can see this observation in our model and in artificial neurons as well. Also, the representation of different categories are really similar to each other. For further investigation, we can see peak latency and onset latency distribution for each category that we are trying to discuss about that. To sum up, we are able to predict the temporal dynamic of neural response in the IT cortex. It means that we provide an encoder for neurons in IT cortex that can extract the feature map of those images that are shown with the temporal information. So by adding feedback, we are able to improve biological inspired models. That's it. Don't hesitate to reach out to me for any question.